Hello, everybody. We're going to do this chapter 2 quiz review together. I'm going to try to zip through this because I'm a little bit short on time. I might have to stop before the end, but let's see what we can do here. Okay, we're going to talk about this graph and we're going to look at where it's increasing. Well, it's increasing when it goes uphill. So this little piece is increasing, as is this piece. So it's increasing from values. This looks like 1, 2, 3, 4, 5, 6. -6 to 1. So the first one is -6 to 1. And then again at 10, 9, 8, 7 to 9, it looks like. So that is choice D for me. And when is it decreasing? Well, it's decreasing here from 2 to, where is it? 10, 9, 8, 7, it looks like. 2 to 7, it looks like. That's that piece going downhill right there. And then it is constant right here from -9 to 6 to 6, -6. So -9 is a small number. -6, which is the big number. It's always small number to big number. Don't forget that. Small number to big. Okay, moving on. Look at this guy. Is there any maximum or minimum value? Yeah, right here is a relative max, and you put the x value here, so the x value is -1, and then the y value is 1. Now you could tell me where the minimum is. Same thing. The minimum value is -31, and that happens at x equals 7. And when is it increasing? Well, it's increasing from -infinity to this first point, -1, and then it's increasing again from 7 to the rest of the time. We use the x values for increasing and decreasing. When is it decreasing? Well, it's decreasing in this middle spot from -1 to 7. Okay, more increasing, decreasing, and constant. When is it increasing? Looks like something to 0, and then again from something to 8. So I can just tell by looking at it as -5 to 0. We use the x values, and then again from 5 to 8. That is when it is increasing. It is decreasing in this region right here. So that's 1, 2, 3, 4. And it stops to further at 6. Small number to big number. Oh, did I miss it? 1, 2, 3. Oh, 3 to 5. I miscounted. So count carefully, guys. And it's constant here at 10, 9, 8, -8 to -5. Okay. Here's the piecewise, and what can we do? Well, the first thing you can do is get rid of the wrong answers. The first piece is going to be an uphill line, not too steep, but positive slope with a solid dot at the end. This has a positive slope, solid dot at the end. This has a negative slope, so this piece is out. Negative slope, this is out, and this one has a positive slope, but it looks like it has a open circle at the end. So just by looking at the first piece, I know that the answer is A. You could also look at the -3. You're going to have 2 open points on the -3, which would also tell you it would be A. Piecewise for this, you have a downhill line, a negative sloped line with a solid dot is going to be our first one. Here's a negative line, but there's an open dot at the end, so it's not it. Maybe this one, not D because it has an open spot. Okay, so next let's look at the new one. Open circle, open circle. These both have open circles, and these both have negative slope lines. So we really need to decide which one of these is the graph of -2x plus 2, because one of them is kind of flatter than the other. The key here is going to be that y-intercept. My y-intercept is 2. This has a y-intercept of 0, so C is my correct answer. Okay, we're going to do domain and range of the piecewise. The domain is left to right, what x is allowed to be. And it's starting here at -9. -9 is the smallest value, and it keeps going to the right, and it stops here at x equals 5. The range is the down up. Notice they put a parenthesis there because the bottom number, -9, is an open circle, which means it can't be -9. And the very top value appears to be at 8. You can zoom in on these graphs if you need to. What is the equation? Okay, well, let's see what we have here. We have a positive slope line, and it's a solid dot, open circle. That is solid dot, open circle, solid dot, open circle. So what's different here? We got an x plus 11 and an x minus 11. If you extend this line, is the y-intercept going to be at positive 11 or negative 11? It's going to be at positive 11. That is the correct equation. Okay, for these, we're just going to plug in values. They want h of -9, which means x equals -9. So we need to figure out which equation fits in there. -9 is in this region for the first one. So it'll be -5 times -9 minus 13, which is 45 minus 13, which is 32. Plugging in the next point, I have h of -5. h of -5 means x is -5. x is -5 will fit in right there. And for this equation, it's just shooting out 3's. Next one, h is 3. They both have a 3, but this is the one where x equals 3. And you will have 3 plus 6, which will give you 9. Plug in the 5. That will also be in the last region. That will be a 5 plus 6, giving us 11. Okay, another piecewise, we have a little flat line and then a little bit steeper. Open circle, closed circle. So this one is a flat line. This one's a little steeper. Open, close. It could be this one. This one I don't think looks right, guys. Look, the y-intercept is coming in here positive. This has a y-intercept of 0, so this is not it. Could be this one, flatter, steeper. This one is too steep to start with, so this one is out as well. So we need to look at these two guys. Our best bet will be to look at this piece for the y-intercept. The second piece y-intercept should be 3. It's counting by 2's. This one is in at 6. This is the one at 3, so my answer is C. Okay, domain and range of this piecewise function. What is x allowed to be here? Well, it's going to left forever, and it's going to the right forever. And right here, it's not part of any graph, but they did put a dot here. So this graph does go to the left and right forever. So the domain is -infinity to +infinity. What about the range? Well, the range is just hopping around. Sometimes it's -2, sometimes it's 1, and then one time it's 2. So the only thing this can be is -2, 1, and 2. And what would be the equation? Well, the first piece is at 1. The first piece is at 1, so it's either the first or the last one. And if you notice, there's an open circle, and they have it. The second dot is happening at -2, 3, excuse me, -2, 2. So the y value is 2, and that's where we get the correct answer. When x is -2, y is 2. So the choice is C. Now we're going to do some problems where we're going to have to do some calculating. F minus g of 0 is the same thing as f of 0 minus g of 0. So what is f of 0? We'll plug it in to function f. That's 0 squared minus 19, which is -19. Minus g of 0 is 10 minus 0, which is just 10. -19 minus 10 gives us negative 29. How about this one? FG negative 1/9. This is the same thing as f of negative 1/9 times g of negative 1/9. Now, when I do f of negative 1/9, it's a little bit tricky. It's not hard, but it's negative 1/9 squared minus 11. You would square the top and square the bottom. That's 1 over 81 minus 11, which is kind of not nice. And I don't have my calculator handy, so I'm just going to leave it there for a second. I'm going to take that times g of negative 1/9. Well, look what happens here. 9 times negative 1/9 plus 1. Those 9s cancel out, and I get a negative 1 plus 1. That gives me 0. What is anything times 0? It's just equal to 0. Let's try this one. F minus g of 8. F minus g of 8 is the same thing as f of 8 minus g of 8. So what is f of 8? Well, that's 8 squared minus 20, which is 64 minus 20, which is 44. G of 8 will be 19 minus 8, which is 11. What's 44 minus 11? That will give us our answer, and we're looking at 33. How about h minus g of negative 6? This is the same thing as h of negative 6 minus g of negative 6. H of negative 6 would be negative 6 plus 3, which is negative 3, minus g of negative 6 is negative 6 minus 2. Well, that's the square root of negative 8, and that's not allowed. So this function does not exist. For the pair of functions, we're going to figure out the domain of the sum, difference, and product. So we have x squared, and we have 7x plus 5, a parabola and a line. There's no risk here. So when you add them, you're not creating a risk. It's still a real number. When you subtract them, you're not creating a risk. So it's still a real number. And when you multiply them, you're not creating a risk. So that's also a real number. The only thing that would not be that would be the quotient if you would divide them. This is asking me for the difference quotient. We know another word for a difference quotient is the rate of change formula. And because this is an equation of a line, that's a fancy way of asking me for the slope. There's no work required for this, but you have to know that they're asking me for the slope. Now here's a rate of change question, and this one definitely requires work. What we need to do, if you remember, the first thing you have to do is f of x plus h. Then we'll subtract f of x, and then we'll divide by h. So the first step is here, the second step is there, and the third step is down below. So the first thing we will do is we will plug in x plus h into our equation. We'll be really careful here because you have the x plus h squared, and that's what causes kids problems. X plus h times x plus h is x squared plus xh plus xh, that's 2xh plus h squared. So I have negative 9 times x squared plus 2xh plus h squared. I'm going to distribute this, plus 3x plus 3h plus 6. One little bit of cleaning up, distribute that negative 9, negative 9x squared minus 18xh minus 9h squared. There's no like terms here, so this is all part of our problem. That's step 1. Now we subtract f of x. I told you, when you subtract f of x, every time you just subtract, you change the sign, these will all cancel out with somebody. So the negative 9x squared cancels out, the 3x cancels out, and the 6 cancels out. So I'm left with negative 18xh minus 9h squared plus 3h. To finish up, we divide everything by h, each piece. Those h's cancel, and I get negative 18x. One of the h's cancels here, which leaves a minus 9h. Both h's cancel there, and you get a plus 3, and that is our answer. Negative 18x minus 9h plus 3. That's one of the hardest ones on the test or quiz or whatever this is. Next one, f over g of 5 halves. That's the same thing as f of 5 halves divided by g of 5 halves. So what is f of 5 halves? Well, f of 5 halves would be 5 halves squared minus 6. Square the top, square the bottom. That's 25 fourths minus 6. And I'm just going to leave it there for a minute to see what happens. 25 fourths, that's really sloppy. So is that 25 fourths minus 6, okay? Divide by g of 5 halves. Well, once again, something weird's going to happen. Negative 2 times 5 halves plus 5. Those 2's cancel. And I get a negative 5 plus 5, which gives me a 0. So g of 5 halves is 0. So I have something divided by 0. Are you allowed to divide by 0? No. So that does not exist. Okay, this one is the doozy problem. All these different functions. Take a look. I have a line. Well, what's the domain of a line? Negative infinity, positive infinity. The next guy is also a line. So it also does not have a risk factor. So also negative infinity, positive infinity. And the next ones I would do together. Okay, so I would get separate paper out and I would go ahead and find f times g of x. So it's f of x times g of x. And that will give me 5x plus 4 times 1 minus 10x. We will have to double distribute here. It's 5x minus 50x squared plus 4 minus 40x. Clean it up. Negative 50x squared. 5x minus 40x, that's negative 35x plus 4. That's what the answer is going to be. They're going to ask me that later. And the domain has no risks. So that is also negative infinity, positive infinity. How about when I multiply f together twice? When I multiply f together twice, I'll get 5x plus 4 times 5x plus 4. Not creating a risk factor. It'll be 25x squared plus 20x plus 20x. That's plus 40x plus 16. And there's no risk factor, so we get, once again, negative infinity, positive infinity. How about f over g? Well, this is the first one that we're going to have an issue. F over g creates a risk factor because when I have 5x plus 4 and I divide it by 1 minus 10x, all of a sudden, this guy can't be 0. So 1 minus 10x cannot equal 0. Subtract 1 from both sides. Negative 10x cannot equal negative 1. Divide by negative 10. And x cannot be positive 1/10. So if you're trying to write x cannot be 1/10, you have to write what x can be. So that is negative infinity, 1/10. Close it. Oops. Union 1/10 to infinity. Kind of touchy on the way we enter it there. How about g over f? Well, g over f is just going to be this guy flipped over. I'm kind of running out of space here. Let's do 1 minus 10x over 5x plus 4. This time, 5x plus 4 cannot equal 0. Subtract 4. 5x cannot equal negative 4. And x cannot be negative 4/5. So what can it be? Well, it can be negative infinity, We'll go all the way to -4/5. Skip over the 4/5 or -4/5 rather, and go on the rest of the time to infinity. Okay, what was my f times g? That was this first one here. I already did that. -50 x squared. I can't see. -35x plus 4. Okay, f times f of x. We already did that one as well. That one's the one right down here. 5x squared plus 40x plus 16. And the last one, f over g, that's going to give us a fraction. F over g, which one was f over g? 5x plus 4 on top. 1 minus 10x on bottom. And they're trying to help you here. They're trying to remind you what to do. 1 minus 10x, we already said what that couldn't be. 1 minus 10x cannot be 1/10, so you're going to put it there again one more time. And the last one, you just flip that guy on its head. 1 minus 10x on top. On bottom is 5x plus 4. And this time it can't be the -4/5. Okay, that is a doozy, but you can get it. And it kind of sucks to type it in, to be quite honest. This would be better done on paper, but at least now you can kind of look at your notes. Okay, let's talk about the domain of these. What's the domain of f? This is just a line, no risk factors, -infinity to +infinity. Moving on. What's the domain of g? The square root of x plus 5. Well, what's up with that? X plus 5 can't be negative, so it's to be greater than or equal to 0, and x is greater than or equal to -5. It can be -5, so it has to have that square bracket. Be careful, don't fall for the wrong one. It has to have that square bracket. Okay, and what if I add them? Well, go ahead and add them. If I add them, I get x minus 4 plus the square root of x plus 5. So this guy still shows up in the problem. So it's the same as that g. What is f plus g of x? I just erased it. I had x minus 4 plus the square root of x plus 5. There's the square root. And what was it underneath there? X plus 5. There we go. Difference quotient again. Here it is. You need to know, what is that asking me? That's just asking me for the slope. It's -8. Another difference quotient. So there was 2 of them. All those parts, we're going to do f of x plus h first. That's going to be 9 minus x plus h squared. Be careful with that minus. That's 9 minus parentheses. What is x plus h times x plus h? X squared plus xh plus xh. That's 2xh plus h squared. X squared plus 2xh plus h squared. So you have to distribute 9 minus x squared minus 2xh minus h squared. So f of x plus h is done. Now we'll subtract f of x. Remember, each piece will get taken away with something. So I'm going to subtract the 9. I'm going to subtract a negative x squared, which really adds the x squared. And all I have left is -2xh minus h squared. But you're going to have to divide all the pieces by h. Divide this by h and this by h, and you get -2x minus one of those h squares cancels. It leaves you with the other one. So it's -2x plus h. Missed it. Minus h. I had it right, but didn't type it right. That's why your scratch work is so important, because if you have it right on your scratch work, I try to give it to you. Okay, moving on to some composing. f of g of negative 2. We're going to start with g of negative 2. G of negative 2 is negative 2 to the third. That's negative 8. So my new problem is f of negative 8. Well, take negative 8, plug it into f, and that's 6 times negative 8 plus 5. It's negative 48 plus 5, which is negative 43. So you do g of negative 2, you get an answer, and you plug it in to the next one. Can you plug it into itself? Sure can. F of negative 3. Well, what is f of negative 3? That's 2 times negative 3 plus 5. That's negative 6 plus 5, which is negative 1. So my new problem becomes, what is f of negative 1? 2 times negative 1 plus 5 is negative 2 plus 5, which gives me 3. F of g of 2. F of g of 2, start with the g of 2. G of 2 would be 2 squared minus 5. It's 4 minus 5, which is negative 1. My new problem is f of negative 1. That gives me 4 times negative 1 minus 1. Negative 4 minus 1 is negative 5. G of f of 2. Start with the f of 2. That's 4 times 2 minus 1, which is 8 minus 1, which is 7. So my new problem becomes g of 7. That will be 7 squared minus 5, 49 minus 5, which is 44. Next, we're going to plug some into each other and find the domain. F of g of x. Well, what is g of x? That's the square root of x. So take the square root of x, plug it in to f, and that's 9 square root of x plus 1. That cap is really important there. So I get 9 square root of x. Make sure you exit out of there, plus 1. Well, what about g of f of x? Well, that would be g of 9x plus 1. Now I go to function g and I take out the x, so that whole square root is going to grow with it. And that becomes the square root of 9x plus 1, but this time all of that goes underneath it. So what's the domain? Well, look at this first guy. What is the domain? Well, the rule is x has to be greater than or equal to 0, and that's the only risk that you have there. So they want it as interval notation, so it can be 0. So you're going to do a square bracket, 0 to infinity. For the next piece, the domain of this guy, this time you have to look at what's underneath. The 9x plus 1 has to be greater than or equal to 0. Subtract 1. 9x greater than or equal to negative 1. Divide by 9, and x is greater than or equal to negative 1/9. Again, it can be negative 1/9, so it gets the square bracket. Goes on for infinity. Getting close here. F of g of x and g of f of x. F of g of x will be f of 7 minus 5x. That tells me to go to function f, take out the x, and put the 7 minus 5x in its place. 10x minus 6 looks good. Clean it up. 70 minus 50x minus 6. 70 minus 6. That gives me 64 minus 50x. Let's go in the opposite direction now. G of f of x. This time it's g of 10x minus 6. 7 minus 5 times 10x minus 6. You have to distribute the negative 5. 7 minus 50x plus 30. Someone's going to make a sign mistake there. 7 plus 30 is 37 minus 50x. Last one. F of g of x will be f of 5x minus 3. That tells me to plug it into f. This is tricky. It's 5x minus 3 quantity squared plus 2. Do this first. Let's do it over here. 5x minus 3 times 5x minus 3, 25x squared, minus 15x minus 15x, that's minus 30x plus 9. I'm going to plug that in next to the 6 here. So 25x squared minus 30x plus 9 plus 2. Distribute 150x squared plus 180x plus 54 plus 2. That gives me 56 at the end. And I get 150x squared plus 180x plus 56. Messed it up. Oh, help me. 25x squared minus 15 minus 15, that's minus 30 plus 9. 6 times 25 is 150 minus 180x. 6 times 9 is 54 plus 2. There it is, minus 180x. Minus 180x. I had a sign mistake, guys. Negative 30 times 6, this should be a negative 180x. And last one here, and then I can go home. G of f of x is g of 6x squared plus 2. Go to function g, take out the x and put in the 6x squared plus 2 minus 3. 30x squared plus 10 minus 3. That gives me 30x squared plus 7. All done. Okay, so that's your quiz review. Actually, I might make the test a couple questions shorter, so the numbers might not be exact, but nothing extra will be on there. That much I can promise you.